All right, we're live, I guess. Howdy, folks. Um, just getting settled in a bit here. I've been doing a bit of work on this yesterday, but I had a lot of trouble with driver just misbehaving, not even initializing for me. So hopefully we'll have a bit of better luck today. Wow, thanks for popping by. um, OBS has been updated, so it seems to be a bit nicer, a bit faster. And I did not actually check, but we should be using VA API, yeah. Very fancy. All right. I think I'll get to it. So this driver existed in downstream. Hey, network exception. Good to see. I think we can get that open here. So, presuming this is visible, yeah. This is the driver which shipped from Qualcomm on pretty much every device from that generation. Like 2018 would have used this driver unless they used external kind of haptics driver. Like the Pixel 3, which used I2C1 instead. This driver is huge. It is 2,500 lines of code, and it supports a lot of different features. It supports different types of haptics, of which there are two, which are like linear resonant actuators and the fancy term eccentric rotating mass, LRAs and ERMs. The second one, eccentric rotating mass, is what you'd be used to if you've ever like taken apart a game controller. It's just a motor with a offset weight on the end of it. So when it spins, it vibrates. However, the vast majority of devices didn't use those because they're not very good, and they're not really that much cheaper. So they just went for LRAs. All of the devices we have in STM845 mainline group all use LRAs of some sort. Other ones that use this driver do at least. So like the Shift 6MQ, the OnePlus 6, and the Pocophone F1. So there's not really any justification to support the other modes. There's quite a few other things that you can configure, which we don't really want to. Those are predominantly, where are they? Somewhere. Oh well. Essentially these. So the actuator type, and then the play mode, a few different supported play modes. Thanks, Ducky. So you can have buffer play mode, which is the standard one where you upload a wave sample pattern like this one. How exactly this is sort of formatted, I'm not too sure about, but it works. There's also, I think they're over here. So there's direct, which is where you drive it from like, I think you stream it in real time or something. Kind of odd. There's buffer mode, which is what we use, what's used generally if you just want to like make the haptics vibrate when you press the key on a keyboard or like open an app or whatever. And then there's audio, where you can actually hook up the PMIC to an audio output. And so you can play like a ringtone and at the same time route the ringtone audio in, and it will make the haptics move in time with it, which is pretty bizarre. And actually, I think the hardware is all hooked up on the Shift 6MQ, so Eritane, nice to see you. Yeah, and then there's PWM, which is very fancy, and also entirely unused as far as I can tell. So we only really care about buffer mode. That's the only important one. So after a lot of work, 2 years ago, I was able to get the driver from 2,500 lines of code down to almost 1,000. And I still kept in a lot of the old stuff, like just in case, I guess. But it's been 2 years and nobody has wanted any features outside of what this already supports. So one of the things we're going to do is simplify it a little bit further. All right. So on the right here is the work that I did yesterday to try and cut it down a bit, down to 700 lines. Unfortunately, I just couldn't get this driver to work. It just didn't do anything. The driver loaded, but this probe function never got called, and I just didn't know why. So we're gonna sort of start again and hopefully not have to deal with that. A lot of the complexity is for things like these, wrong file. There's custom read write wrappers. So this is read wrapper, which just calls regmap bulk read. There's no need for this to exist. Yeah. There's also this is secure address thing. So this is for addresses greater than where is it? Oh, right, yeah. If the least significant, or wait, endianness. Yeah, if the least significant byte is greater than an OXD0, hey there, then it is a secure address, and that essentially means that to avoid like accidentally writing to it, you have to knock on a different address to unlock the register, which is what all of this does, and it's a bit of a mess. And this is secure address stuff. There's only one register which makes use of it, which is the test2 register, which is used to enable and disable auto resonance for some reason. Yeah, so this is rather strange. It's strange that downstream does it, and it's strange that it does it in the way that it does. So this is the downstream driver again. And if you find that test2 register, here it is. For some reason, on PM660, which is a different but similar PMIC, they just had this auto resonance control. But for PMI 8998, which is what I'm implementing here, they have this, they read it to this other register, and it's this test register, which is really, really strange. I don't quite understand why that's done the way it does, done the way it is. Yeah, so I'd kept all of this in, but I don't think it's needed. So what we're going to do is rename this to be our old driver. And then we'll have a new one here, and we will do a few things. We'll stop Clang format from touching these because the Clang format configuration in the kernel for some reason doesn't space macros properly, and nobody's fixed it. So we'll get rid of that. We'll get rid of most of this. I think we'll throw it all away. Fantastic. We'll start from scratch. So this is sort of a template for a driver. I think we'll adjust these types to be this instead. I don't really know what the standard is with these, but this seems fine. We get rid of that, and yeah, slab. Okay, so this sort of template is what you'd usually end up with when you're implementing a platform driver, or at least it's what I usually end up with. I could be completely wrong, and there's much better ways to do this, but you need a platform driver definition to define your like probe, remove, shutdown, or various other callbacks you can implement. And then the driver itself has a name, has some power management operations. So here we have this callback, which will get called every time the device goes into suspend. And that makes sure that it doesn't trigger the haptics whilst you're going into suspend. Because if you do that, then the device will be asleep, but will be like vibrating in your hand, which is probably not what you want. And then very similar thing for removing the driver. So most of the stuff we need, this has got a very long name, which we can improve like so. This atomic variable, I don't think we need. So that's another thing we will get into, I guess. So probing a driver, we need to set up, allocate all our memory, I guess. Sorry. Yeah, so there's a lot of kind of regular boilerplate stuff which you need to do. We can be a bit lazy and just copy and paste this stuff. So essentially here we print a big message to make sure that we know that we probed. This is very important. All drivers should have this, I think. And then, yeah, so we allocate memory. Nice thing about working in the kernel, which you don't get so much in user space if you're just using C, is this device management framework, DevM. I don't know if that's actually what it is called, but essentially you can allocate memory for things that you need to use and you don't have to worry about freeing it. So this memory allocated here for our kind of state struct will be automatically freed when the driver like exits, which is very handy. Makes my life a lot easier. So we need a register map, which we get from the parent in this particular case. So the way that works is here in the device tree. This is the device tree for the PMIC. This single PMIC chip, the PMI 898 chip, has two kind of, I don't know, logical, I don't remember exactly what LSID stands for, but it has two address spaces for all of the peripherals which live on it, and it has like the charger block, some GPIOs, an ADC, the fuel gauge, and over here we have our haptics. So the PMIC is communicated with over SPMI, which is a proprietary power management interface developed by Qualcomm, and it is pretty standard. It's quite similar to I2C in terms of like how we use it. So this whole LSID will have its own address space, and that's essentially what we're getting here. So we're getting the register map, which is a concept inside the kernel of like literally a map of registers you can write to. And from that register map, or we use that to talk to the haptics peripheral. So we could actually talk to any component on the PMIC here. There's no protections in place, but because we're all in kernel space, it doesn't matter a whole lot. Hi there. I won't attempt to pronounce your name, but I like it. So yeah, we got our register map. That also makes some things really nice and easy. For example, it's all 8-bit values and 16-bit addresses, and we don't have to care about that. The regmap kind of framework does all of that for us. So yeah, we need a device node, which is actually just used for making the code a bit easier to read. So first thing that we do is we read the address of the haptics peripheral. So if we go back over here to the device tree, we have haptics on here, and they have this address OXC000. So this value is what will get read by this call here. So it reads the property named reg, and it reads it into the haptics base address property. One thing which we should drag this over here, I think. So we're in this old driver in the probe function, if I can find it. There's a lot of this similar thing, DevError, printing the return value and then returning. Since I wrote this driver, I think, or around the same time, this new function got introduced. There's this new helper called DevError Probe, where you give it the device and you give it the return value, and then it will print that there was an error and print the return value and print whatever message you give it, and then return the return value. So essentially, rather than having to do this with the same format string every time and then having to return, we can just simplify it to return DevError Probe. And it makes printing of errors a lot more consistent and stuff like that. So it's quite a nice addition. And saves a line of code for every single one. This is also nice. We will come back to these. Or actually, yeah, we'll grab these now as well. So these are the values which we don't support changing, as the comment states, I think. Actually, it's type. We only support LRAs. We only support buffer play mode. The wave shape, there's a few different ones, which are here. Sine and square wave. Sine wave is just better. Hot take. Square wave supporters, don't add me. Alright, so next up, this is a bit of copy and pasting code for now. I promise it will get a bit more interesting, but this is actually the only real important thing that we need, which varies per device, is the wave play rate, which is essentially the resonance frequency of the actuator. The way that these types of haptics work is that you pick the strength, which is the voltage that it will vibrate at, but the frequency it does it is usually fixed. And in order to work efficiently, it has to be vibrating at its resonant frequency. So yeah, that's essentially per actuator that you get. So the 1+6 has a certain type of actuator which has a specific resonance frequency. And the haptics hardware in the PMIC has some auto resonance features, which we will also get into a little bit. But essentially, by resonating like this, you get way more powerful, feeling haptics than if you weren't. That's what makes it feel so sharp and proper, I guess. If you've used the haptics on an iPhone, you'll be pretty familiar with that. Those are very well tuned. I'll take it, these vibration motors suck anyway. Yeah. Unfortunately, it's one of those things where a lot of vendors tend to cheap out on it. And then they also don't even bother tuning them properly. So that's why we end up with them being a bit crap. So these properties, this is also read from device tree, but yeah, that gets set here on a per device basis. So this value is taken from downstream. All right. So I guess it's worth talking about kind of how you structure a driver like this. This driver works using the input device framework, hence why it's in drivers input. And essentially you have the what's it called, FF memless force feedback interface, which was designed literally for use with game controllers. And we create an input device which only supports rumble is the name of it, force feedback or rumble effects. And that's it. So then we have this callback play effect where we get given the effect, which just for rumble just contains the magnitude, how strong the rumble should be. The API supports controllers that have a strong rumble motor and a weak one, and it controls both of them, but we don't have that at all, so we have to do some not very fun things to sort of coerce it into values that make sense. So once we do that, this play effect function is called. As far as I'm aware, we are not really meant to hang around in this function. We are meant to return fairly quickly. We'll see if we can find out, but play effect. Who even knows? Because I sure don't. This is very curious. There's a lot of different ways you can do this. The way that is implemented in this driver, or this old one, I guess, is that the haptics start and then you return. Essentially, in the play effect handler thing, you just go, okay, cool, we need to start playing the haptics. And so it schedules a work thread, which then does that. And then when you want to stop, there is another callback, which is like, I think it calls play effect again, but with 0 magnitude. And at that point, we then go, okay, cool, and we stop it. And then the next time we schedule the work to run, it will realize that the haptics are currently playing and it will stop them. And that works okay. This particular driver, it does not work very okay because I did not understand how locks work. It uses an atomic variable for some reason, and it's not ideal. So I think we could simplify it all by doing everything in the play effect handler. Because I think we should be able to do that. Maybe. Oh. It never tells us. Gosh. So, as far as I'm aware, it's not possible that play effect would be called twice, like at the same time. I think all the events have to be queued. What does this suggest here? Yeah. This sets a lock. Cool. So yeah, so we should be able to simplify this quite a bit. So we have our haptics play stop work function, which we will now be able to get rid of entirely. Unless I'm totally mistaken. So yeah. And we shouldn't even need the mutex at all. Alright, fantastic. So we will just go right ahead to this. Or I suppose we should finish initializing the hardware first. Mutex. I get the feeling you don't like mutexes. I love mutexes. They're great. As long as you don't deadlock. They're less great then. Okay, let's finish this off first, shall we? So, you gotta be really careful when implementing your probe function to avoid bad things happening. An example of that, which this old driver dealt with in a very bad way, is this work function here. So this work function is scheduled to happen by the short circuit IRQ handler. If it detects a short circuit, like the actuator has blown up or something, there's some safety mechanism, then it will. Where are we? Oh, we're in the new one. It was confused there. Yeah, so it would create the work, initialize it, is good, and that happened after. Oh well, I don't remember the details. I will summarize. Essentially, the ordering is slightly wrong. It would be possible that you'd register the interrupts, and then you'd initialize the hardware, and the hardware would immediately fire an interrupt, and then you'd be handling that interrupt before the probe function is even finished running. And then that's how you can end up with like null pointers and crashes during the kernel booting, because yeah, that happens, which is quite bad. So registering interrupts is kind of one of the last things you generally want to do when that's a concern. Because sometimes you need to initialize the hardware and it's expected that you immediately get an interrupt. So yeah, it's one of those things that I'd never considered whatsoever until it happened. So where are we here? We got the play rate. We don't want the work. We need to initialize the hardware. Very important. We will implement this function shortly. And then we get to create the input device. Woo. This is all fairly standard stuff. For some reason, my IntelliSense is not being very good today. All right, and then we do this IRQs. Somewhat ironically, this is also just more unnecessary complexity here. This play IRQ, we don't actually use it at all. The play IRQ is meant for when you have large buffers that you want to play. So you might have like a pattern similarly to playing audio. Instead of doing that, which can be a bit complicated and intensive, I don't know, for whatever reason, you can also just have arbitrary buffers. So you can have a ringtone with an associated like haptics wave sample that you would then upload. And because there's only a limited amount of memory in the hardware, it would fire this play IRQ, and in the IRQ handler, you have to then like send it the next chunk of data to play. So yeah, lots of fun, lots of capabilities that seem really cool, but at the end of the day, what are you going to do with them? I would totally love to see somebody make use of this stuff and make something cool with it, but yeah, I guess the haptics just, once you get them working, aren't that interesting. Okay, we need our IRQ handlers. This short circuit IRQ is very exciting. It has to do a lot of time tracking and checking of things to figure out if we really are in a short circuit event or something else. typing on the keyboard is much easier with feedback. I totally agree with you. You could have your haptics play a little jingle every time you press a key. I think that would be pretty fun. There's some fun little things up here which I think we want. Relatively basic stuff. So Vmax is the voltage, the maximum voltage that you're like vibrating at. So it's what's set when you call the play effect handler. You tell it the magnitude, and then it gets mapped to Vmax. Something even better than haptics, the notification LED. Yeah, that works even, I think. I think people made that work. Turns out on my OnePlus 6, which I use for development, I spent like, I think I spent an hour or two trying to figure out why it wasn't working, but it just worked fine for somebody else. So I think my particular device is just broken. That's fun use of time. All right. So this haptics enable control register is just that. As far as I am aware from some comments in downstream, if you write a 0 here, everything will just stop, which is super nice to have and to know about. It would be fantastic if we had proper documentation for this, but unfortunately, all we really have to go on is the downstream driver as reference. Function returning a function is not allowed? Oh, dearie me. Oh well. Yeah, so this player IQ we don't actually care about, but we implement it anyway. Just for the sake of it, in case anybody wants to make use of it in the future. I'm not really sure if we should bother with that or not. With me and Joel had broken LEDs. Oh yeah, I remember Joel mentioning that. That's pretty funny. It must be, I don't know. I wonder if maybe like an older version of the driver just immediately burnt out the LEDs, and we'd both tried it independently, and that's why. But who knows? So I'll quickly summarize this. If I can remember how it works, we essentially check if the haptics are in short circuit by reading the status register. We get the current time, we check the time against the last time there was a short circuit interrupt, and we check, we basically count how many short circuit interrupts fire, and if enough of them fire within this, is that 10 seconds delay? Then, what's the max count? 5? Yeah, if we get 5 of them fairly quickly, not a good time, so we just disable the haptics, which is totally fine. Mutex try-lock here, I'm not too sure about. Locking the mutex, calling mutex lock would obviously block, and we might not want to do that, but yeah, I don't know. One of those things where I'm not really sure what the smartest thing to do is. And there's no way of testing because we simply can't. We have like a few devices. We certainly don't have the time. So yeah. What's that? uint8t. I think that'll do. Great. So we've got our keys. We got our probe. We need to do our init function. So this needs to program kind of sensible values for everything. A lot of these are kind of spread around downstream because all of this stuff is configurable. So it was quite a lot of work to kind of condense it down into just what we actually need for the like one type of configuration we even use. And this is kind of what we've ended up with. So we configure the auto resonance correctly. I think. Then we give it what? The play mode, right? The current limit, there are 400 and 800 milliamps. We just set it to 400 as I think that's what everything uses, and we don't want to go burning out haptics. It's a bad time. So the debounce, wave shape, very important. Yeah, and then it gets a bit complicated, and I have no idea how I managed to make this work in the first place. So this is kind of don't touch it territory. And then we have this break pattern. So it's something really cool actually. Once you want to stop the haptics, it does a break to like make it stop as fast as possible, because if it just cuts power to it, then it will still vibrate for a while, and so you end up with like really mushy feeling haptics. So to counter that, it has a break pattern where it will essentially send like a specific signal in reverse phase to how the haptics is playing. So it's like if you are swinging somebody on a swing and then you start trying to slow them down. It's essentially the same effect where you push them away as they're coming towards you and pull them as they are swinging back away. If it's like a really heavy swing or something. So that's great. This default break pattern is this. I don't really know why I came up with this, because it's actually different to what everything uses on downstream. We should fix that back. We also have this wave sample pattern, which again is like, yeah, the encoding for this, you can figure it out. I think the documentation in downstream actually explains it, but I don't remember it. And I think these values should work okay. So we'll just leave it as is. But that will configure the actual kind of wave that it is doing, I guess. All right, so yeah, where are we at? Here we got the play wave rate, the frequency, and yeah, auto resonance. I don't know if I explained that, is effectively the thing. I did go through that, but that is what makes it go very fast. As just regular old driving the haptics at whatever frequency you like, it doesn't work that well. But when you make it resonate, it really likes it. Right. More stuff we could drop, but as buffer mode is the only one supported, but I think it's worth leaving in just in case somebody tries to add a different play mode because their device uses it, and then they run this and it burns out their haptics or something, that wouldn't be very good. Yeah, so that's mostly that. We need our write break pattern function. This is kind of pulled out just to make things a little bit tidier, even though it's only called from one place. And it will make, yeah, supporting more break patterns a bit easier in the future. Great. And then we just have a vibrate and stop vibrate functions. Something missing down here, play effect, right. Fantastic. So the whole thing of like having work items or a work function where you essentially have this function you want to call, and then from this context or like a interrupt context or whatever, you schedule the work to happen, and then it gets queued on a worker thread where you don't have to worry about like blocking for a long time or whatever. I don't think we need that because we can just, all we're doing is writing a few registers, and it seems like the input event stuff is designed to handle that okay. So rather than doing this, we will call this one here and this one here. So yeah, with any luck, that's mostly it. Oh. So this haptics vibrate was a bit more complicated over here. SPMI haptics enable, this is what it was called. And it configures like the auto resonance by writing to this test2 register. And I really don't know why it does that. Does this on downstream. I thought maybe it's a workaround for like a bug or something, or hardware limitation, but yeah, who knows. So I suppose it is time to see how many errors we get. Grab my USB cable here. Now, on the bottom right, I believe you can see on the top is the UART output from the device, and on the bottom is the kernel logs from my PC. So should be able to see it booting and stuff that way. Now, I hope we don't run into the same issue I had yesterday where for some reason this function just doesn't seem to get called, and I really don't understand why. So we'll cross our fingers and hope that we've cut about 350 lines of code from this driver, which is pretty good. This is the first driver I ever wrote, and it's very odd. There's a lot of yeah. Took me a really long time to understand how some things worked. But fortunately, now 2 years later, I have a much better understanding. I had actually gone through, I think, 4 revisions of attempting to upstream this. You can find them if you search for like SPMI haptics on the kernel mailing list. And I got a lot of very helpful feedback. But fundamentally, the approach that I kind of taken to it was not really ideal. And I ended up getting busy with other stuff, and it worked well enough. So we've been shipping in post macOS for 2 years, but it's definitely about time I kind of got rid of it, so we don't have to carry it for any longer. So let's see. It simplifies things a bit. Get rid of that. SPMI haptics close. Very important. We'll make sure that if you open the input device and then you send a play event to start playing the haptics, and then you close it again, it doesn't just keep going. That would obviously not be very ideal. So here, instead of this atomic read, we will do like is module enabled? I do not remember the name of the function. Up here somewhere. Great. So if the haptics module is enabled, then we will stop vibrating, which will disable it. Very important. Great. Get rid of all of the stuff calling the work function. And yeah, I wonder if it's possible for somebody to open the input device fast, but actually that shouldn't really matter here. Yeah, so we register the input device. So assuming that we do this and then somebody like really quickly opens it, then it's fine. The IR keys won't be there, but that doesn't matter. They can't do it like whilst we're initializing the hardware or anything, because we do that earlier. So there shouldn't be any possibility for race conditions here. And we have this mutex here. I also don't know if we need it. I kind of think that we don't, but maybe it's helpful in cases of short circuit so that it doesn't try and handle the short circuit and then we immediately turn the haptics back on or something like that. Oh. Haptics disable. That's our haptics stop vibrate function. Great. I had the really smart idea of renaming some functions rather than fixing it and then renaming functions, which has made this a bit confusing. Having worked on haptics on both Qualcomm and MediaTek phones, kind of funny how Qualcomm made this super complicated block with a bunch of smart stuff, while MediaTek just hooked up a motor to an LDO. Yeah. Yeah. I definitely get that. I think Qualcomm tried to offer a sort of all-inclusive thing, but clearly this, despite the complexity here, it's still not good enough for like the really flagshipy phones, I guess. I mean, the Pixel 3, for example, used I2C controller to drive its LRA. I guess there are other reasons they could have done that, but I'd presume it was for higher precision, which I guess this didn't provide. Anyway, we are now, we have compiled a new kernel and installed it. And we are rebooting the device. And for some reason, we're not getting any UART output. It's because the UART isn't plugged in. So fiddly. There we go. Much better. All right, so here we are. Haptics Probe 1. Heck yeah. Let's see what we can do. So EV test shows that it's input event 4, but that doesn't let us test rumble effects. We need FF test for that from Linux console tools. Dev input event 4. And I guess we'll cross our fingers. Wow. I don't know if you can hear that, but it works. It actually works. I'm in shock. That is first try. I mean, yeah. I don't know. I did not think that was going to work, to be completely honest. Wow. I think it's a little better. I did tweak a few behavioral things. I guess we'll see how it feels in Phosh. If it feels anything in Phosh. Yeah. Oopsies. That was a kernel panic flying by, wasn't it? It was. I typed too fast. I see. It doesn't seem to like me locking the mutex. I think that's what the problem is here. Do we have a better scene for this? Ooh, we do. Here we go. All right, so yeah, so I have to have write, input event dispose. And then here in mutex lock, yeah, scheduling while atomic. Right. So I believe the play effect callback is meant to be like a atomic context, or that is probably the wrong terminology. We're not allowed to block, so we're not allowed to lock a mutex in here because that would be bad, I guess. So this function call happens in a blocking context from the cooling application, which is like feedbackd in this case. So feedbackd tries to play the effect, it jumps all the way down the kernel stack and ends up in here. And so if we then like wait for a mutex, I think specifically when the mutex is locked. So because I was tapping really fast, it tried to lock the mutex while it was already locked, which caused it to try and then like, wait for the mutex to become available, and that caused the bug. And the kernel splat. So we will actually need a work item thing. Very fun. All right. I think we can simplify this a little bit by doing So writing it to Vmax and the magnitude from this context could be a race condition thing. It definitely could. That's very frustrating. Let's see how the PM8XXX vibrator driver handled it. Just like that, huh? I guess that makes some sense. Okay, so we'll get rid of this. I don't know why magnitude is like a property of the haptics thing, of the struct, because it's only used in this function. So we'll do away with that. Do it like this instead. We'll get our work item back. And be very careful of those darned erase conditions. We gotta, so we initialize it here and then I guess that's fine. Sure. A little worried that we init work and then we, failed to probe and return an error, and then it tries to queue the work item or like do anything with it. No, that's not how that works. I am dumb. All right. We are good. Oh yeah, can't forget to initialize the mutex. Okay, so init the work item, which we need to allocate. Great. We'll get that defined up here. So this we queue. So rather than doing all the stuff that we were doing in here, we just do the magnitude bit and then we just queue the work item. And we get rid of that. Great. And the work item will lock the mutex and then cool whatever needs to be cooled. I think we'll do a +1 here. And then yeah, okay, wait. So to make sure that we don't get mixed up and accidentally if for some reason you try to play at the minimum possible magnitude but it's non-zero and then you end up with this being the minimum, we need a way to know if the play effect was called to turn the haptics on or turn the haptics off. We need to be fairly sure of that. One thing that we do is check if the actual hardware is enabled by reading a register, but better to be safe than sorry, I think. So yeah, so if the hardware is enabled, or if the hardware is not enabled, and we have a defined Vmax value, then vibrate, otherwise stop. Makes sense. It should be safe, I think. Let me just get rid of our magnitude up here because we don't need that anymore. Oh, and there as well. Okay, let's see how we go. Oh no, we had the wrong scene open. Whoopsies. Oh, this is where we're meant to be. My mistake. We essentially just reintroduce this work function. Not very well, apparently. So we introduce this work function as if we try and lock the mutex in here, and the mutex is for some reason already locked, such as if you're typing very quickly on a keyboard. Not allowed to do that. That's a problem. The kernel tells us off because we are not meant to be blocking in this context. because this is called directly from like a user space process, so we need to return fast. So instead of that, we need to just assign our values. In this case, we set Vmax, depending on whether or not the play effect had a magnitude value or not. And then we schedule the work to happen, which will actually control when the haptics like starts or stops. Awesome. So hopefully, oh, this should be enough to get things going again. If not, maybe it's time to just rewrite it in Rust, you know? That's the trending thing nowadays, I think. I have to admit, I am actually pretty excited about Rust in the kernel, even though I am a terrible Rust programmer. The language is so confusing. I would have set up a second camera that kind of can see the phone, but it was a bit too much effort today. Well, on the plus side, our haptics still work. And now they work no matter how quickly we type. Yay. Fantastic. I'm going to call that a big win. Was not expecting to get this done quite so fast, but I'll take it. So I guess, yeah, we can clean up, commit our codes, back up this old file somewhere else. Squash these commits. Oopsies. And we should end up with a commit for our device tree bindings and a commit for our driver. Now the real question is, do I send it as a v5 on top of the v4 which I sent, actually I think I have it open. V4 I sent in December 2021. So how long ago was that? About a year, right? I guess. Yeah. I think we'll restart from the beginning. I think that makes a little bit more sense. So we can get format patch. Maybe I should send a v5. I think it should be a v5. That makes sense. We also want to include a cover letter. So there we go. And then we run check patch. Ooh. Gotta run Clang format. Still unhappy, huh? Creating white space. Alright. Missing blank line. Sure. Brace is not necessary. Very true. Oh. I gotta make sure we cancel the work item here as well. We do it there. And we do it in close. No need for the the mutex. Yeah, no need for that. Because there can't be anything else running because we cancel all the work items. Alright. Prefer GPL over GPL2. Sure thing. Awesome. We have some checked patches ready to submit. So I guess we'll do that. What was the subject line I was using before? It was introduce support for SPMI haptics. Hi Nima, nice to see you. You never got Jordian working? Oh. Yeah, that's a shame. It can be a bit of a challenge, but it definitely pays off to never give up. It took me a really long time to be able to do the things that I wanted to do and work on the things I wanted to, but you'll get there. Introduce support for Qualcomm SPMI haptics. I like it. Wow, I wrote a lot. What did I write? This series introduces driver for the SPMI haptics. Hardware block found in Qualcomm PMICs. PMI haptics support LRA as well as ERM. This support for LRA haptics and buffer mode. Sweet. Yeah, sometimes taking a break is a good idea. Even if you don't feel like you want to. Yeah, so what have we done? Significant rewrite, I guess. Significant rewrite. Uh, uh, One thing I did forget to do is get rid of this very noisy debug print. Oh, right, and the one down here. And we can't forget the device tree bindings, which need to be fixed, I think. PMI 8998. PMI haptics. Here they are. And yeah, I think we can simplify things a bit. Yeah. We currently don't support setting any of these, so we'll move them up to the rest of the driver. Great. And we'll delete this file. Update the copyright. Fantastic. Suggestions for learning deeper. Good question. Unfortunately, one of those tricky things to do, I guess. Kernel development. I mean, was you're in roughly the right place. Seeing more about how people do that, and watching talks and just kind of picking up that information is definitely a good thing. There's also this, I wrote this blog post, which I'll link you to, where it kind of hopefully points in sort of the right direction for Linux mobile stuff, but I think it's mostly applicable to like a lot of different projects, whatever you might find interesting. How do I do things over here? I'm really bad at doing these damn device tree bindings. Ah, great. That'll do. I suppose I should rename this to something like how the charger is now named. SPMI haptics is a bit vague, and given that it only supports one generation of Qualcomm PMICs, or a few very closely related generations, I think this is kind of reasonable. If Tunis is still here, I'm sure they have some thoughts on that, but it's unfortunately really difficult to categorize different generations of like Qualcomm stuff. Makes naming these things a bit of a pain. There's already PM8XXX vibrator, which is a bit old and doesn't support, like, it's a different generation of hardware, and it has a completely different like register map and stuff. So we need a new driver for this because it is a fundamentally different thing. But PMI 8998 comes under PM8XXX. So yeah. What do we do? we're getting there. Alrighty. Things are cleaned up. Let's make a backup of our cover letter. And then run through check package again. Oh, DT binding docs and include should be a separate patch. Oh, the header file is in the all right. There we go. This is kind of the boring part. I do apologize. But if I don't do it now... Oh wow. Forgot about this. Let's pop this up here. Look at that. I wrote a whole wiki page on this stuff. I'll drop a link in chat for anybody who might be interested. Stupidly complicated hardware, to be honest. Yeah, if you care to, this explains in a lot more detail than I have how things generally work in downstream. And how the hardware itself works. So yeah, lots of flexibility. nice part about working with simple devices like a mice is that it can't be too complicated because it wouldn't fit on the thing. True. Yeah. It is a bit ridiculous how much stuff is stuffed in these PMICs. One chip does the haptics, does battery charging, does USB PD support, does all the regulators for driving all the things like the touchscreen, drives the backlight, drives LEDs. Like the list just goes on and on. It's amazing. Don't know. This'll do. This is fine. Alright, we got patches. We got the pass check patch. Can do the thing. Just to email them to myself first because I do not trust my ability to not mess things up. Yep. Whoopsies. Accidentally signed the patches off with my work email. Oop. Oh. I am going blind from the sun, which is now reflecting off the windows of the house. But lack of docks is still a problem. Yeah. Alright. For your custom mouse firmware, that does sound like a challenge. Even worse when they're not even reference drivers. However annoying they may be to understand. Alrighty. That's not what it says in the from box. Oh, the cover letter. Yeah, embedded stuff is always very scary. Yeah. I've always found the only way for me to learn is to lose days of my life trying things, because you never really find the documentation that tells you what, like, how to do what you want to do. So you got to deal with just, yeah, the rest. Let's see, can we do it? Can we send an email? I think it will fail. Potatoes. If needs the buzz, buzz. That's very true. Proton mail bridge. Don't fail me now. Damn. Unable to initialize SMTP properly. Reveal your secrets. Ah. Is this what was missing? They're not specifying my identity. The mouse connector is a Bluetooth keyboard. Wow. That's the best kind of mouse. It works. We can do it. We can send the emails. It is 1990 all over again. Fantastic. Can't enable both Bluetooth and console output. Oh. That does not sound like fun. I had a sort of similar thing with a 3D printer recently, because, yeah, doesn't have very much space, and I was trying to make use of the fancy auto bed leveling features and stuff, which take up a lot of space. Turns out that I was doing debug builds, and instead just doing release builds gave me loads of extra space to work with, because in my case with that, the modifications I was doing wouldn't really cause like runtime crashes or anything, so all the debug symbols were just taking up space that I didn't need, or rather that I did need. So yeah. So there's a few specific people I think we want to CC. Who are they? Ah, it's fine. Let's see what this says. This seems to be give or take the right people. I'm still getting used to this new kind of CC command thing. Still this very nice little script from somebody which generates the CC list. It's a lot better than what I was doing before. And let's see. Wow. All the people. I hope they like patches. Let's do it. Take it back. I forgot to test boot again. Gotta do that. See? Imagine. Oh, actually, this is unrelated to my patches, but still. That would not have been the first time I've accidentally sent patches after making last minute changes and forgetting to actually even compile them. Get a bit stuck in the zone. That's not great. But hopefully I did not make any mistakes. We shall soon see. As the phone reboots and fails to do anything useful. That's my prediction. Oh my god. I actually managed to break it. Oh, no I didn't. No, I didn't. It just has a different event number now. Yeah. Yeah. Yeah, that definitely vibrates. Oh gosh. That was a scary moment. Alright. It works. I am happy that it works. Now we send our patches. Let's go. Ubuntu Touch and WageRoid. Awesome. That's a good combination for sure. Yay. Let's see. Are we live? Nope, not yet. They take a little while. All right. Well, that was a very productive, hour and 2 hours? Gosh. Getting it done so quickly. Thank you. I did spend a few hours on this last night, so it wasn't all done today. A lot of today was kind of copy pasting and checking things. Most of the hard cleanup was done, but hopefully it was still somewhat interesting. Now we just gotta wait for the patches to show up on the mailing list. I'm pretty sure that law.kernel.org has some caching actually, so if you request the page and it's a message not found thing, it will cache that. So even when it does actually show up, it will take even longer because the URL was cached. Yay, there it is. Woohoo. It's all here. I did not run DT bindings check. So that's good. Whoever gets the flash working will be the happiest person to ever turn on a single LED. I absolutely agree. There are binding check issues. No. Bah. Whoopsies. Always has to be something. QPNP flash v2. This is what you're looking at. This is the downstream flash driver. It is 2,900 lines long. Yeah. There's a good reason nobody's looked at this yet. No fun at all. Alright, let's fix the DT schema. That makes sense for a start. QCOM wave play rate. Think we got away with it this time. Alright, that's a bit annoying. But we get to send a v6 now. Looked at it and understood nothing. The flash driver, yeah, I think I've done the same a few times. There's a very good chance that it could be condensed down to like similar sort of size to this, where it only needs to be like 700 lines of code or something, but you gotta understand enough of it first. Okay, we'll generate our v6. Copy our v5 cover letter. Fantastic. Great. Overclocking messes up touch. That's very weird. No. Oopsies. Almost deleted everything there. Oh yeah. Oh dearie me. I always manage to make such a hash of this. Does the Pocophone F1 have a video mode panel? I thought it was command mode. Or, I guess it is video mode. Nice that you can overclock it at all, because you simply cannot overclock command mode panels. Or not usually, at least. Because of how they work. Alright. Make sure that this still functions properly. It does function. Yay. Oh. Oopsies. We have some typo corrections already. Fantastic. There's a bluish glow after displaying something bright in one spot for a few minutes. Yeah, that's not ideal. Alright. I send more patches and I hope that developers don't get too annoyed at me. And I think we're about ready to call it a day. Yeah, I should be grabbing some food and hopefully getting closer to finally cutting down on that damn, what, I think 80 something patches that we carry on top of mainline currently for the Snapdragon 845 devices. If we get this in, that's 2 patches. We get the charger in, which I resent recently, then that's another 2 patches. And then all of the device tree patches that go with them, which usually are sent separately now to kind of make the process a bit easier. So that's another like patch per device plus at least one more, I think. There's quite a lot of patches that are just pretty simple stuff that we should be getting upstreamed in the not too distant future. So yeah, fingers crossed for that. Alright. Patches have sent. Hopefully they're a bit nicer looking now. And I'm going to take my leave. Thanks everybody who showed up to hang around. I will no doubt see you again. Yeah.